The capacity of a cuboidal tank is 50,000 liters of water. Find the breadth of the tank if its length and depth are respectively 10 meter and 2.5 meter. Capacity means volume. So volume of cuboidal tank equal to 50,000 liter. Now we can't work in liter, we need to work in meter cube. So how do we convert liter into meter cube? For that they have given here 1000 liters equal to meter cube. So do we divide or do we multiply by 1000? Now see, 1000 liters becomes 1 meter cube, the number decreases. So for that we'll have to do 50,000 divide by 1000 to give into meter cube. So, and this would be 50 meter cube, and this is the volume. Then the length is given as 10 meter and the breadth is given as 2.5 meter. For a cuboid, the volume of a cuboid formula length into breadth into height. So we have the volume is 50, length we saw is 10, breadth 2.5 and height is h. So 50 over 10 into 2.5 is equal to h. So 50 into 10 over 10 into 25 equal to h. Here I have removed the decimal, that is why I put the 10 here. This decimal is removed, that's why I got the 10 here. So this is 2 meter equal to the height. A wall is 15 meter long, 30 centimeter wide and 4 meter high, is made of bricks each measuring 22 centimeters by 12.5 centimeter, 7.5 centimeter. If 1/12, here is a mistake, that if 1/12 of the total volume of the wall consists of mortar, how many bricks are there in the wall? So first we have a wall. A wall is a cuboid and the dimensions of the wall are given as 15, 30 and 4. So length 15 meter, the breadth is given as 30 centimeter. So I'm just immediately going to change it into meter, that is 30 over 100 divided by 100 meter, 0.3 meter. And the height is 4 meter. So we find the volume of the wall. It's a cuboid. So volume of wall, length, breadth into height, which is 15 into 0.3 into 4. So volume of wall works out as 18 meter cube. Now we also have bricks here, which we'll look into it later. Now here they said 1/12 of the total volume of the wall consists of mortar, which means mortar is a cement. So volume of mortar equal to 1/12 of the wall. This is what they've said, 1/12 of the wall. So mortar is a cement, is 1/12 of wall, which is 18. So volume of mortar will be equal to 1.5 meter cube. So now the wall, this wall is made up of two things. It's made up of the bricks plus the mortar or the cement. We know the wall was given as 18. The volume of the bricks we don't know. The total volume of all the bricks. Mortar was 1.5. It is 1/12 of the wall. So the volume of the bricks equal to 18 into 1.5. 16.5 meter cube the volume, total volume of bricks, of all the bricks. So we need to keep that in mind. This total volume is important. Now we're going to find the volume of one brick and then divide to find number of bricks. Now remember, the dimensions of the bricks are 22 centimeter, 12.5 and 7.5 centimeter. So for bricks, dimensions: length 22 centimeter, breadth is given as 12.5 centimeter, and the height 7.5 centimeter. I need to convert into meter, so 22 over 100, which is 0.22 meter. Same thing, this also breadth will be 0.125 meter, and here when you divide by 100 you get 0.075 meter. So volume of bricks, volume of one brick, not volume of bricks, volume of one brick equal to length, breadth into height. 0.22, 0.125, 0.075. But I'm not going to multiply and find the volume. Now we have to find number of bricks. So number of bricks will be the volume of bricks, the total volume of all the bricks, divide by volume of one brick. Or I could write this a little another way: volume of brick, of all the bricks, divide by volume of one brick. Now total volume of all the bricks we already found was 16.5, and this is divide by one brick. That would be 0.22 into 0.125 into 0.075, which is 16.5. The division becomes multiplication, so it would be now 1 over 0.22, 1 over 0.125 into 1 over 0.075. To remove the decimal, I multiply here by 100. To remove this decimal, I multiply by 1000. To remove this decimal, also I multiply by 1000. And if you work this out, you get the answer N is 8000 bricks. So here this was the wall. Now this yellow part was the bricks, and there were 8000 such bricks in this wall. But the total volume of the bricks was not the volume of the wall, because the wall was also in between. There was this mortar, the cement, to cement the bricks up, and hence we had to subtract that, and this mortar was 1/12 of the wall. So in order to find the volume of bricks, what we needed to do was we needed to find the volume of the wall and minus the mortar. That means it was wall minus 1/12 of the wall, because they said the mortar was 1/12 of the wall, and then what we got was volume of the bricks, which was 16.5 meter cube. The whole wall was 18, but the bricks was only 16.5 meter cube. Then to find number of bricks, we found the total volume of the bricks, because we are finding number of bricks, divide by volume of one brick. The volume of a cuboid is 1536 meter cube. So let's write that. Volume of cuboid 1536 meter cube. its length is 16. So length 16 meter. The breadth and the height are in the ratio 3:2, which means the breadth will be 3x and the height will be 2x. Now for the formula, volume equal to length into breadth into height, and that is 1536, length 16, 3x into 2x. We need to find x, so 1536 over 16 into 3 into 2 is x square. When you work this out, you get x square equal to 16. So x equal to under root 16, x equal to 4. Now the breadth was given as here 3x, so it will be 3 into 4, which is 12. And the height was taken as 2x, 3, that is 2 into 2x, so 2 into 4, and which was 8. So the answer, breadth equal to 12 meter, height equal to 8 meter. The capacity of a closed cylindrical vessel of height 1 meter is 15.4 liters. So here we have the height of a cylinder. We are dealing here with a cylinder, a closed cylinder. The height is 1 meter, and they said the volume is 15.4 liter. We never work in liter, we got to convert in meter cube. And if you remember, what was the conversion? It was 1000 liter equal to 1 meter cube. So from liter, if you want to make meter cube, we get a smaller number. 1000 becomes 1. So we need to divide by 1000. So we are going to now divide this by 1000 to give us in meter cube. So 15.4 over 1000 meter cube. Now the volume is given as of a cylinder. The formula for volume of cylinder, pi r square h. Now we put our values. So we have volume is 15.4 over 1000, 22 over 7 r square. Your h is given as 1. So I remove the decimal, and because I remove the decimal, down I have to add another 0. So equal to 22 over 7 r square. We cross multiply, so I have 154 into 7 over 1000 into 10 into 22 equal to r square. When you cancel this out, you get your r square as 49 over 10,000. When you reduce it, so r will be under root 49 over 10,000. So r will be 7 over 100. R will be 0.07 meter. But we are not done with the sum. We need to find now the metal sheet needed to make it. It's a closed cylinder. So the metal sheet needed to make it will be total surface area of the cylinder. So here we got radius as 0.07 meter. We know the height of the cylinder is 1 meter, and it is a closed cylinder. We need the metal sheet to make it. So the area of metal sheet equal to TSA, 2 pi r plus h. 2 into 22 over 7. Your r is 0.07, 0.07 plus 1. Now to work this, you get 22 over 7, 7 over 100, 1.07. Now this cancels out, and you will get here 44 into 1.07 over 100. This is 47.08 over 100, which means 0.4708 meter square is the area of the metal sheet required. The inner diameter of a cylindrical wooden pipe is 24 centimeter and the outer diameter is 28. The length of the pipe is 35. Find the mass of the pipe if 1 centimeter cube of wood has a mass of 0.6 grams. Here we have a hollow pipe. So this would be the inner part, and then which is hollow, and then we'll have the outer part. There will be two cylinders here. The inner will be a hollow one and the outer, this will be the outer. So we'll make two. We have the outer cylinder and then we have the inner cylinder. Now here it is given to us that the inner radius is 24. So inner diameter is 24, so the radius will be 12 centimeter, and the outer is given as 28, so the radius will be 14 centimeter, and the height of the pipe is the same, is given 35. So height for the outer is 35 and inner is also 35. Now to find the wood is in this region, right? And for that we have to subtract outer minus inner. Outer volume minus the inner volume. This region will be the wood. In the middle it is hollow, so we have to subtract the outer volume from the inner volume. So we have the outer volume, which is pi r square h. Pi, the r is 14 square, h 35. So when you work this out, you get 6860 pi, the outer volume. This outer volume. But because the inner volume is now the inner volume is this inner one is hollow, we need to subtract. Here this is the inner one, has to be subtracted because it is no wood there in the middle. So now we'll find the inner volume, pi r square h. Pi r is 12 square, h 35. You work this out, you get 5040. Don't substitute your pi, we'll do it later. Now when we want to find volume of wood, it will be outer volume minus inner volume. Outer volume is 6860 pi, inner volume 5040 pi. On subtraction, 5720. On subtraction we get 1820 pi. Now we will substitute the value of pi as 22/7, and the volume of the wood comes as, after putting 22/7 you substitute and you get 5720 centimeter cube. Now there's another part of the sum. We have to find the mass. They said 1 centimeter cube weighs 0.6 grams. So 1 centimeter cube weighs 0.6 gram. How many centimeter cube do we have here? We have 5720 centimeter cube, which will be equal to 57, the weight of this will be, into 0.6. And this would be equal to 3432 gram. Find the volume, the CSA and the TSA of a cone having base radius 35 centimeter and height 12 centimeter. So we are dealing with a cone. So first we go and find the volume. Volume of cone 1 by 3 pi r square h. 1 by 3 pi 22 by 7. The r is given here 35. We'll just write here. So 35 square. The h height is given here 12. And you need to work this out. So that will be 1 by 3 into 22 over 7, 35 into 35 into 12. You cancel this, ones are here 4, this you cancel 5. Now what is left is 22 into 5 into 35 into 4. And that works as 15400 centimeter cube. That is volume. Now next we will find the CSA. Now to find the CSA, the formula for CSA is pi r L. And if you notice, the L is not given. R is given to us as 35. The height is given as 12, but there is no L. Now what is the L? This is your cone. We have, this is the radius r, this is the central height, and this is a slant height L. This is 90 degrees. So we can use Pythagoras theorem here. So we have L square equal to r square plus h square. 35 square. No, this is L is not given, so I can't write 35 here. So we have L square. The r is 35 square and h square 12 square. So L square, the 35 square is 1225 plus 144. So L square becomes 1369. So L will be under root of 1369 and L will be 37. Now that we have L, we can find the CSA and the TSA. So of this cone, the radius is 35 centimeter. The height is given as 12 centimeter, and we found the slant height as 37 centimeter. Now to find the CSA, pi RL 22 by 7, R 35, L 37. So when you cancel this, you get 22 into 5, 7 and 35 you'll cancel, get 5 into 37. So which is equal to 4070 centimeter square. Now to find the TSA, TSA of the cone is pi R, R plus L. So 22 by 7, the R is 35, 35 R and L was 37. So this is 22, I cancel this, I get 5 here, and 35 plus 37 would be 72. So we'll multiply, and this would be 7920 centimeter square. That will be the TSA. TSA means it is the entire, this base, which is pi r square, here pi r square area of the base, plus this is the CSA, which we found as pi r L. If you add both, you get your TSA. Water flows at a rate of 10 meters per minute through a cylindrical pipe 5 mm in diameter. How long will it take to fill a conical vessel whose diameter is 40 centimeters and depth is 24? So here we have a pipe. Water from this pipe is poured into a conical vessel. And for this conical vessel, they have given the diameter as 40 centimeter here. So the radius is half, 20 centimeter, and the depth is given as 24 centimeter. So since we are filling it with water, definitely we have to find the volume of it. So we find volume of cone 1 by 3 pi r square h. 1 by 3 pi. Your r is 20 square, h is 24. So we work this out. So here we get, this is 9600 pi over 3, and we can even do it further. 3200 pi is the volume of cone. Now we need to know how long will this pipe take to fill this cone. Now what are the dimensions of this cone? The diameter of this cone is given as 5 millimeter. So radius is half of it, 2.5 millimeter. We can't work in millimeter, we are working in centimeter. So 2.5 over 10 centimeter is the radius. Now the water travels at the speed of 10 meters per minute. So in 1 minute it covers a distance, we'll say height is 10 meters in 1 minute. We'll again work in centimeters. So 1000 centimeters in 1 minute. So the height in 1 minute, this height in 1 minute, it covers 1000 centimeters. So that would be like the height, and the radius we know is 2.5 over 10 centimeter. So we'll find the volume of water here for 1 minute. This volume of water will be that pours into the cylinder for 1 minute. So volume of water for 1 minute equal to the volume of that cylinder, pi r square h. That is pi, your r is 2.5 over 10 the whole square, and the h is 1000. So that is pi into 2.5, 2.5, do it up here. So pi 2.5, 2.5, 10 into 10 into 1000. This is the amount of water for 1 minute. 1 minute is this one cylinder. So when you work this, so for n minutes it would be n into, so n into this entire volume. This volume was for 1 minute. So for n minutes here, it will be n into this whole. Now all this water gets poured from the cylinder, gets poured into this cone. So I can say now volume of water from cylinder equal to volume of cone. Now cylinder volume is n, pi into 2.5, 2.5 thousand over 10 into 10 for n minutes, which is 3200 pi. You cancel the pi out. To remove this decimal I put a 10, to remove this decimal I put another 10. So 1, 2, 3, 1, 2, 3, I cancel out. Now to find n, I do 3200, I take the denominator 10 on the top, then here I get 225 into 25. And you cancel this out and you will get the number of minutes. So the n works out 256 divided by 5 minutes. Let's summarize the sum again. Here we have to fill this conical vessel. So we find the volume of this conical vessel by using the formula 1 by 3 pi r square h. Now to fill this vessel, all the water comes from this pipe here. And the speed of the pipe, S, the water flowing through it, is given as 100 meter per minute. we convert into centimeters, so it become 1000 centimeter per minute. That means in 1 minute it covers a distance of 1000. So you find the volume of this cylinder, which is pi r square h. Now that is for 1 minute. This volume is for 1 minute, but it takes more than 1 minute to fill this pi r square h. It takes n minutes. So for n minutes the volume of water will be n into pi r square h. Now this water all goes into the water from here, flows all into this cone. So we have volume pi r square h, volume from the cylinder or from the pipe goes into the cone. So we equate this, and that's how we get the time, that is n minutes. You can put t also instead of n. How many spheres of 12 centimeter diameter can be made from a metallic cylinder of diameter 8 and height 90 centimeters? First we have two shapes. We have spheres on one side, and here the diameter is given as, of the spheres is given as 12 centimeter. So radius is 6 centimeter. And then here we have made into a cylinder. It could be also a wire. Wire also, remember, is a cylinder. So cylinder, and of cylinder the diameter is given 8 centimeter. So radius is 4 centimeter. And the height is given. So height here is 90 centimeter. Now we have to find how many spheres. So we have, say, 1, 2, 3, 4, 5. We don't know how many spheres. Say n spheres. These n spheres are melted to give a cylinder, to give the cylinder of this dimension. So our equation will be volume of spheres equal to volume of cylinder. Now volume of spheres, volume of one sphere is 4 by 3 pi r cube. But we don't have just one, we have n spheres. So volume of n spheres will be n into 4 by 3 pi r cube. So that is n, 4 by 3 pi, and we saw the r, so it will be 6 cube. Now this is all melted into a cylinder. Now volume of cylinder is pi r square h. Pi, the r is 4 here. 4 square h, 90. Now this volume of sphere is made into the cylinder. So volume of sphere is equal to volume of cylinder. And now we cancel the pi on both the sides, and we need to find the value of n. That will be 4 into 4 into 90. We take it, so 3 by 4 from that side, and over 1 over 6 cube. So here it's written it a little tidier. So now we need to find n. Pi will cancel. So you have 4 into 4 here, 4 into 4, and this is 90. Now we take 4 by 3 on the other side, become 3 by 4. We take the 6 cube. Now this is, we know this radius is 6. It's given to us here 6. So we put 6 cube here. That goes on the other side, become 1 over 6 cube. Now we find the value of this. And when you work this out, you get your n equal to 5. So you get 5 spheres. So I'm going to erase this. You need 5 spheres. No, 4, 5, yeah. 5 spheres to get into that cylinder. The volume and surface area of a solid hemisphere are numerically equal. What is the diameter of the hemisphere? Here we are dealing with hemisphere, half a sphere. The volume of it we know is 2 by 3 pi r cube, and the surface we know is 3 pi r square. And here they said volume is numerically equal to surface, which means 2 by 3 pi r cube equal to 3 pi r square. Pi pi cancels. And now see what happens here. 2 by 3. R cube means R, R, R. R square means R, R. So these two R's and these two R's will cancel out. So we have R equal to 3 into 3 over 2. So R will be 9 over 2, and that is 4.5. So radius 4.5 centimeter or unit. They have not told us the unit, so we cannot write anything here. We just write unit. So diameter is 2 into 4.5, 9 unit.